Hello guys, a very good afternoon to everyone. Welcome to Global Online. So today we are here to prepare NTA UGC in June 2024 cycle. In today's session, we are going to take the business statistics unit. Okay, and yes, this is Dr. Swati, your educator. Before we start our session, let's quickly tell you about the Global Online. Here you will get a complete course on the commerce and management. Here you will get daily live lectures, complete syllabus notes in the PDF form, full syllabus mock test and PYQs with the detailed solutions, and the MCQs practice sessions is more thousand 4,000 MCQs we are going to conduct, and paper one is free of cost if you register yourself for the paper two, and for registration you will get 20% discount on the fees. So if you register yourself for paper two, then you will get paper one is free of cost. So the contact number is given in your screen, so get in touch with this contact number for more detail, and if you have any kind of query. Okay, so how do you download the global knowledge? Just go to Google Play Store, then type the global online, and just download the app, and just register your name, and your register yourself with your registered mobile number. Then you search your whatever the course do you want. Then here if you register once your uh, register yourself, then you will get all the information, all the materials, all the recorded lectures in the proper folders. Okay, so you can recognize all the folders very easily. Now let's start with our session, that is what is the statistics. You know that what is a statistics? Statistics is nothing but it is a mathematics. Okay, it's a nothing but is a mathematics, is a arts, and also it is a science. Okay, also it is a science. So why it is a science? Because if we are taking the facts as a calculation. We are concluding the facts. Okay, and why it is hard for concluding these facts, we need to present it very well. So their presentation, how do you present the data, how do you collect the data? So this is a kind of a art. Okay, the statistics is a branch of the applied mathematics that involve the collection, description, analyzing, and interpretation and conclusion from the quantitative data. That is in the mathematical, in the numerical terms. So statistics is a further statistics is divided in two categories, that is a descriptive statistic and the next one, that is inferential math statistics. So what is a descriptive statistic? That descriptive statistics include the organizing the data, summarizing the data, simplifying the data, and describe and presenting the data. So this is a description, how you describe your data, how to present your data, how to simplify your data, how to classify it, how to organize it, this data. So this is about the description. What is the inferential? Inferential means where you draw some hypothesis, where you test your hypothesis, make a prediction from this hypothesis. When you test your hypothesis, so when you predict this hypothesis means a prediction. So the things is happening or not happening. So this kind of prediction, generalizing from the sample to the population. So we can't take a whole population as a data, as a sample. So we take a just small part of that population, that is called as a sample, and from that sample we calculate our conclusion. Okay, then the measures of the central tendency. The measures of the central tendency, this is a part of the statistics, and this use of this measure of the central tendency, we will calculate the statistical, we will measure the values. Okay, and the entire there is a huge data set is for the calculation. So we see it's unable or it is difficult to calculate single values. Okay, so the central tendency play a very vital role. The central tendency involve mean, median, and mode. Okay, so these three are the main central tendency of the statistics. So the central tendency state the statistics measure that represent the single value. Okay, represent a single value of entire distribution of data. If I take a five, if I this is a 500, this is a population. From that population, if I take a sample, okay, in this sample, the sample is of the 5,000. Suppose the 5,000 students in that sample. So it is a difficult to get the all the data from a single students. Okay, so in that case, what we have to do, we have to consider that is a see if we take a group of the student, okay, 10 group of the student. If we check that if we from this student, if we are we study on the one student, so this one student represent all these all the 10 student group, and from this 10 student group we conclude the sample. Okay, so the single value of the entire distribution of data, it is aimed to provide accurate descriptions of the entire data in the distribution. Okay, now the central tendency are further divided in the two parts. The first one, that is a mathematical average, and second one, that is a positional average. So mathematical average means where you calculate your mean. Okay, where you calculate your mean. Positioning means the data set is a show the position, that is a median. Median means in the whole data set the middle value is the medium. And what is the mode? Mode means the most frequently repeated value. Okay, repeated value in the data set, in the data set. Okay, most repetitive value. And further, the mean is divided in the three the categories, that is the arithmetic mean. We calculate the mean in the in the way of the arithmetic mean, geometric mean, and the harmonic mean. So we will see the one by one. That is a in the arithmetic mean. In the mean, arithmetic means it is a nothing but an average. Average is the ratio of the sum of all the observation to the total of the observation. So what we do the sum of all the observation. If the observation is x, so the sum of all the observation and the number of the observation. So in this case, we will calculate the arithmetic mean. Now the median means a middle number of the sorted ascending order. We first of all we have to arrange the data in the ascending order or a descending order, and from this data we take a middle value. Okay, and then the mode is the value of the appearing the most frequent in the data set. So most frequently repeated value, that is a mode. Okay, now the geometric mean is what? The geometric mean is the average of the value of the mean, which signify actually the geometric mean is calculated for the mean calculation. So it is signifying the central tendency of the state of the number by finding the product of their value, basically multiplying the number together. Geometric mean when we use a log table. Okay, when we use a log table, so from this log table, we take a nth root of the multiplier number. Okay, where n is the total number of the data set value. Here in the geometric, in the simple way, in the geometric way, we use a log table. In the harmonic, it's a harmonic. Harmonic means it is a reciprocal. Reci, reci, that is a reciprocal. Reciprocal of the value, that means if the 70 is given, so the reciprocal of the value, that is 1 divided by 70. Okay, 80 is given, so the 1 divided by 80, this is a reciprocal. Okay, now if if the consent B is added or subtracted from every observation, the mean of these observation will also get added or subtracted by it. So there's a condition is given: if every observation is multiplied, okay, or divided by the constant B, then the mean of this observation also get multiplied by it. So the relation, actually the show the relationship of the mean with their observation. Okay, if we add or subtract, subtract it from the, if we use addition, that means it is affected by the origin. It is not affected. Mean mean is not affected by the origin and scale. Okay, so what is origin? Origin means where if we add or if we subtract, there is a no difference, okay, in the mean value. And in the scale means if we divide something or if we multiply something, in that case there will be no difference in the mean. Okay, then the next, that is the sum of the deviation. Sum of the deviation means sum of the dx. Okay, observe from the arithmetic mean is always be 0. Yes, this is true, it is always be 0 because we take a deviation from the middle of the value. So the plus 1 is the minus 1 is the data is look like this, and the middle from the another part is plus 1, plus 2, and plus 3. So the summation is always be 0. So the sum of the deviation of the observed from the arithmetic mean is 0. The sum of the square deviation, that is sum of the square deviation, that is the square of the deviation observed from the arithmetic mean is minimum. Okay, it's minimum as compared to anything, as compared to mean, median, mode. Sorry, mode and medium. Then the arithmetic mean is capable for being the treat algebraically. Okay, so the sign, the plus minus, we can treat it algebraically. Now the properties of the geometric mean. Geometric mean of the given data set is always less than what? Always less than the arithmetic mean. That means arithmetic mean is greater than geometric mean. Clear it? So it always be less than the arithmetic mean of the data set. Okay. If each object in the data is set is a substitute by the geometric mean, then the product of the object remain unchanged. Okay, if we substitute, okay, if substituted by the geometric mean, then the product of the object remain unchanged, it will not going to be changed if we substitute, if we find any kind of substitute. So there is a unchanged by the origin and by the scale. Okay, now the ratio of corresponding observation of the geometric mean in the two series is equals to the ratio of their geometric mean. If we calculate the ratio, the corresponding observation of the geometric mean, okay, so the two series is equals to the ratio of the geometric mean. Now the product of the corresponding item of the geometric mean in the two series are equal. Okay, to the product of the geometric mean. The product of the corresponding item, okay, of the geometric mean in the two series, if the x series and y series is given, is equals to the product of the geometric mean. Okay, now the formula is given, that is arithmetic mean is summation of the, you can see dx divided by the number, or you can use the, that is if the x is a is given a plus b, arithmetic mean is nothing but we're taking the average of, okay, then the geometric mean is a root 3 a multiplied by b multiplied by c. Either you can write that is a summation of the log s divided by number. Okay, then the harmonic mean is nothing but a reciprocal. Okay, so this formula is right, that is 3, that is number divided by 1 by a plus 1 by b plus 1 by c, this kind. Then the property of the median. Property of the median means outer layer and the skewed data. So properties of the median. So median's property is a less than, is having the less impact on the median. Outer layer skewness means because the data is exactly between the middle of the area. So the outer layer, outer layer and the skewness. The skewness is a do not affect the median. Okay, if the distribution is skewed, okay, the median is better measure when the compare to the mean. If you see the distribution is skewed, it's not is reflecting like this. So in that case, you can see the median is better. Median is better measure than the mean. Okay, now the median is not dependent on all the data value set of the median. Yes, because the median is not dependent, because it's focus only on the median. So it's not focus on the other data set of the data. Median value is fixed by its position. Yes, the position is decided, the middle is and it's not reflected by the individual. So this is also a drawback. Okay, this is a drawback back of the median. Okay, then the distance between the median and the rest of the value is less than the distance from any other point. Okay, here you can see the distance from the median and the rest of the value is less than distance from the any other point of view. Okay, then ever array has been single median. Okay, they do not have a different medium. Ever array, the median cannot be manipulated algebraically. Okay, it cannot be weighted and combined. So the median is not manipulated by algebra. Sorry, algebraic, because not algebraic, because it is a middle, it's a set on the middle. So that's why it's not affected by the minus values, and it's not going to be affected by the plus values. So it cannot be weighted and combined. In a group of the procedure, the median is stable. Okay, the median is not applicable to the qualitative data. Yes, definitely, because the statistics is for the quantitative data. The value must be grouped and ordered for computation. Okay, then the median can be determined from the ratio, interval and ordinary scale. Here you can see the median can be determined by the ratio also, in the interval also, and in the ordinary scale also. Okay, now just a second. Now the properties of the mode. So the properties of the mode, that is, a mode is not unduly affected by the extreme end. It's not affected by the extreme. Why he say that it's not affected by the extreme end? Because a mode is the most repetitive value in the series, in the data set. So it's not is not affected by the extreme value. What are the extreme value? If I write, for example, we have we have a 1 5 6 5 9 2 5. So it is affected by the extreme value. If we are going to arrange this in a proper sequence, that is a 1, then the 2, then 5 5 5 6 9. So the starting the extreme ends are 1 and 9. So is it affected by this 1 or 9? No, there is no relation. Here the value, which value is most repeated, this value is the mode. Okay, then the mode is not a calculated on all observation in the data set. Okay, mode is not calculated on all the observation. Yes, the mode is ignoring this all the data set, only and only focus on the repetitive value. The value of the mode can be computed graphically, whereas the value of the mean cannot be calculated graphically. So mode can be computed graphically, yes, but we are unable to calculate mean in the graphically calculation. So how do you see this in the graphical? That is the most repetitive. This is a graphic. So the most repetitive value means if the 5 is repeating 1 2 3 4 5, 5 is repeating, that means it show this like this. So this is the most repetitive value. Yes, now you can see that the mode can be computed graphically, whereas the value of the mean cannot be calculated graphically. Then the value of the mode can be calculated in the open-ended distribution without knowing the class limit. Yes, because the mode do not need any kind of the class limit. Okay. it is a open-ended. Okay, it's open-ended distribution without knowing the class limit. Now, the mode can be conveniently found even if the frequency distribution has classed input interval of the unequal magnitude, provided that the model class and the classes succeed and succeed it at the same magnitude. Sometimes it may not be possible to calculate a mode in this happening if the data has been binomial bimodal distribution in which there are two possible values of the mode. So what are they? So the formula is given for the median. Median. The formula is given for the median. Okay. This is the property of the mode. Now the median is if if it is a odd one. In the case of the order, the values is odd. So in that case, the formula we have to use, that is x n plus 1 divided by 2. For the median is even. So in that case, in the even number, the half of the xn, so the formula is this. Okay. Then the even. Okay. Here you can see the L is a lower limit of the median class. Okay, N is number of the observations. C is the cumulative frequency of the class preceding the median class frequency. F is the frequency of the median. H class size. Okay, now the formula for the median is is when we will get median in the point form. Okay, so the formula is L plus plus in bracket F1 minus F0 divided by F2 1 minus F0 minus F2 and H, where the lower limit of the model class. Okay, L is lower limit, H is the class interval assumed to be, and F1 is the frequency of the model class, F2 frequency of the preceding model class, and F2 is a succeeding model class. Okay, now the empirical relationship between the mean median mode. Mean median mode, mean uh, mean means a minus z is equals to 3 times of mean minus median. Okay, so this is a relationship between the mean. You can see the mean is greater than median, and median is greater than the mode. Okay, so this is a positive relation. In that case, the skewness is going to be in the left side, skewed in the left side. So this is like this. So this is a left side. So um in that case you can see the relationship mean minus mode is equals to 3 times of mean minus median. Okay, then yes, if the mode is equals to 3 times of median, okay, and 2 times of mean, how do we calculate it? Let's look here. That is here you the we need a mode, so here mode is, we keep it mode as it is, and here the 3 mean minus 3 median. Okay, so the mode and 3 mean means 3 means the we take this mean to the right side, so the plus, so here we write it mean. So here 2 mean minus 3 median. Okay, Now, measures of dispersion. What is the measures of dispersion? What is a dispersion? Dispersion means getting a disperse or getting a separate from the given data. How the value, how the calculated value is dispersed from the given data. Numerical data likely to be vary about the average value. In the other word, dispersion help in understanding the distribution of the data. Okay. Now, the measures of the dispersion is that they are having a two kinds. Okay, the first one, that means absolute measure, and second one, this is relative measure. So we will start with our measure. Absolute measure, having a range. Okay, having a quartile deviation, having a mean absolute deviation, then the standard deviation. So these are the absolute measures of the dispersion. Okay, now the relative means a coefficient of the variation. This is a relation. Coefficient of the quartile deviation. That is the coefficient of the quartile deviation. This is also the relation. It show the actually coefficient, show the relationship. So that's why the relative measures are coefficient of variation, coefficient of quartile deviation, coefficient of mean deviation. So this is a relative measures. Okay. Now the formula is given for the absolute measure and the relative measure. Okay, for the absolute measure, that is the range is L lower minus upper, L minus S. Okay, then in case of a coefficient of the range, in the simple range L minus S, in the if the coefficient of race you can, we the formula is L minus S divided by L plus 1 plus S. Then the quartile deviation, the formula for the absolute is Q3 minus Q1 divided by 2. Then the coefficient of the quartile deviation Q3 minus Q1 divided by Q3 plus Q1. Okay, so it is a coefficient, combinedly efficient. How they are combinedly efficient? In case of quartile deviation, the Q3, the simple, that is Q3 minus Q1 divided by 2. Okay, then the mean deviation. What about the mean deviation? Mean deviation is the summation of frequency dx divided by number. Okay, in the coefficient of the median, that is a md divided by the median. Okay, then the standard deviation is under root of. Okay, you can write it standard deviation under root of summation of dx square divided by n minus summation of dx divided by n the whole square. Okay, so this is the formula of the standard deviation for the absolute measure. For the relative, you know about the standard deviation. Also, just divide with the mean, and mean is yes. So the coefficient of standard deviation and the standard deviation divided by mean. Okay. Now the variance will go, we have calculated the variance with the, if we square the standard deviation, we will get a variance. Then the coefficient of variance, that is, how do we calculate? That is standard deviation divided by mean multiplied by 100. Okay, so this is the mean. You can see. So x is nothing but a mean. Okay, now the range is the simplest quantity that it can be used to measure the degree of a dispersion and the spread in the given data. Okay, so how much degree of dispersion in the given data? Simple. Range is difference between the largest value, where it is, difference between the largest value with the smallest value. Okay, then the property of the range is, the value of the range is always non-negative. Yes, the value of the range is equals to 0. Okay, if and only if you give the set of the data value are all the equal to each other. In that case only the value of the range is going to be 0. Okay, then if the range is non-zero, and we can conclude that the given data value are not all equals to each other. So in okay, so this is a non-zero. The conclusion is drawn by that a given data value are not all equals to the each other. Now for the continuous frequency distribution, we can find the range by subtracting the with the lower limit of the smallest class, okay, from the upper limit of the highest class. Okay, when the finding the range of the frequency distribution, we do not consider the frequency of the classes. The value of the range is independent of the change in origin. Okay, if the change in scale, it will affect the property of the range. Now the formula for this, that is the range is equals to maximum value whatever is given and the minimum value. That means L lower minus S divided by lower plus S. So this is a coefficient of the range. So we are just going to end over here. Okay, we'll continue our session tomorrow. Okay.